right, hi there. We are going to talk about complex numbers today, and this has been something that's kind of come up off and on throughout this chapter where we talk about getting an imaginary answer. So that's what we're going to bring it in today. Something to remember, complex numbers really encompass everything. Complex numbers, that could be something, it could just be like 7. It could be 1/2. It could be -4. All of those are complex numbers. But it also can be imaginary numbers. And that's usually what we're referring to when we talk about complex numbers. So it's going to be something like the square root of a -1, or the square root of a -7, or just 3i, something like that. And so all of these are part of the complex number system. So when we take a number or a complex number and we put it in standard form, we usually will put the real part first, and then we'll put our imaginary part second. And so typically what you're going to see is something that looks like 5 plus 4i, or something like that. And the 5 is our real part, the 4i is the imaginary part. Now, when you're dealing with complex numbers in standard form, here's a little rule that we go by. It says a plus bi is equal to c plus di. If and only if a equals c. Well, that's just saying that, hey, this real part here needs to be the same as this real part here if these complex numbers are going to be the same. And it means that this coefficient on your I needs to be the same as this coefficient on the I if these complex numbers are equal. So let's look at a couple problems where we're comparing those complex numbers. In this first one, you have a plus bi equals 10 minus 3i, and we're supposed to figure out the a and the b. Well, this one's pretty straightforward. The a is the real part, and so when I look over here on the right, the real part is a 10. So a better equal 10. All right, the b is the imaginary part, and so over here when I look at what's the imaginary part, well, the b, or the coefficient on my I, is a -3. All right, so that's pretty simple. That's probably not going to be typically what I give you for homework problems. It's going to look something a little more complex like this next one. All right, so kind of got a mess here. You just got to recognize that this is your real number here. And so I come over here and say, what's the real part? Well, this does not have any I on it, so that's the real part. Over here, I've got a -4 as my b, or my coefficient on my I. And over here, I have a whole bunch of stuff that's the coefficient on my I. So to figure out the a and the b, I'm just going to set things equal to one another. So for the a, I would just have to say a plus 7 needs to equal -6. Subtract the 7, and you get -13. So a is equal to -13. When I'm working on the b, I have 2b minus 1 must be equal to a -4. So let's distribute, and then add the 2, and divide by 2, so my b would have to be -1 for these two complex numbers to be equal to each other. All right, so you just have to kind of pick out the real part, set it equal to the real part. Pick out the imaginary part, set it equal to the imaginary part. Remember, I didn't really even involve the I in this. You can just leave the I out of it. You're really looking at that coefficient on the I. Let's look at doing some operations with complex numbers. They're really pretty straightforward because you really look at that I like it is basically just like a variable, an x. The one thing that you have to watch out for, I should have mentioned this earlier, I don't have a good spot to put this here now, but the one thing you have to remember is since I is equal to the square root of -1, if you square both sides, then you need to remember that I squared is equal to, well, the square and the square root go away, so it just equals a -1. So anytime I come across an I squared, I'm going to replace it with a -1. All right, so let's do a little bit of operations with this. So when I'm adding two complex numbers, all I got to do is add the like terms. So I'm going to add the real parts, the 4 plus the 7, and then I'm going to add the imaginary parts. I've got a negative 3i and a 6i. That gets me a positive 3i. Simple as that. Okay, if you're doing subtraction, you got to watch out for distributing that minus sign all the way through. This minus sign needs to go all the way through, so we'll distribute it to both of those. All right, the other thing, like this example, is way more complicated looking than the previous one. So when I'm working with this, I'm going to kind of look at what I have going on. I've got a 5, that's real, minus a root 5, not pretty, but is doable. Okay, minus, and then I have an 8, that's fine. And then I have this root negative 20. I really need to simplify that right off the bat. And so what I'm going to do with that is break it down. And I'm going to move upward because I have a little bit of space up here. You really want to break it down to what goes into it nicely that you can pull out. But that negative on there, I'm going to pull out also. So I'm going to pull out a negative 1, and then I'm going to go with a 4 and a root 5. And so what that simplifies to, the root negative 1 is going to be I, and then I'll have a 2 root 5. So this is really going to be a 2 root 5 I. And since I'm distributing the negative, it's actually going to end up a positive. And then my 8 is going to be negative. So this is what I really have when I've cleaned that up. And over here, I'll just leave this one the same for now. And then I'm ready to, okay, and since I distributed the negative, that's now going to be a plus sign. And so now I'm just going to combine like terms. So my real parts, I got a 5 and a negative 8. That's a negative 3. And on my imaginary parts, I have a negative root 5 and a positive 2 root 5. So think of this as a negative 1 root 5, and a positive 2 root 5 would get me a positive 1 root 5, or a positive root 5 I. Okay, so some of them will be a little bit more complicated. Let's try number 3 here. On this one, I'm actually squaring this quantity. And so there's a couple ways to do that. You can go just 8 minus 2i times 8 minus 2i, and do FOIL on it. You can also do the shortcut if you remember the shortcut. In the end here, I'm going to have an 8 times 8, that's a 64. Outer is a negative 16i, inner is a positive 16i, and last is going to be a positive 4i squared. Okay, and sorry, I goofed up there. These signs actually are both minus on my 16i. Did you catch that? Those are both minus 16i's. Okay, so now let's combine what we can. Well, these 16i's will certainly work together. And remember that this I squared that I have is actually a negative 1. So this right here, this 4i squared, actually is a negative 4. And so that will always get to be combined with my real number. So I have a 64 with a negative 4 is going to get me a 60 minus 32i. All right, let's try this number 4 here. On this one, it'd be very tempting just to call that the square root of 24 and then go break it down. The problem is if you do that, you are totally ignoring the fact that those are imaginary numbers because you can't square root a negative. So what you have to do is kind of like I did at the beginning up here on this, I have to pull out that negative 1. So what I'm going to do is call this root negative 1 root 3 times root negative 1 root 8. Actually, let me take that back. Let's go ahead and break down the root 8. Actually, no. You could do this a couple ways. I think I'm going to leave it as the 8 for right now, and then I'll come back and reduce at the end. Either way would work. But what I want you to recognize is this is really an I. So you've got an I times a root 3 times an I times a root 8. All right, so that's going to be a root 24. I can multiply those, and I'm going to have an I squared. And now the square root of 24 does break down. I could have done it earlier. I'll do it now. Square root of 4 and the square root of 6. And the I squared is really just going to be times a negative 1. So the square root of 4 is 2 times the negative 1 would get me a negative 2. And then I have a root 6. Okay, last one. Kind of running out of room on this one. I'm going to change colors just so you can see it a little bit better because it's getting cluttered. I have a fraction here with a 3 over 6i. Remember that I is the square root of negative 1, and we don't like to leave radicals in our denominator, so leaving an I down there is kind of like that. So we try to get rid of it. And just like you get rid of a radical in the denominator, remember way back from chapter P when we practiced radical stuff, we got rid of it by multiplying by the radical. So in this case, I'm going to multiply by the I, but I've got to do it on the top also. So what that gets me is a 3i over 6i squared. All right, remember that the I squared is really a negative 1, so that's going to make my fraction negative. The 3/6 could reduce to a 1/2. And the I would just sit there. So it's basically going to be like a 1i over a negative 2. Is that what that would reduce to? Okay, so I've got a 1/2, and the I squared makes it negative. This 1 up here is probably optional. We would rarely write that 1, so I'm just going to write I over negative 2 for my final answer on that one. All right, so that's kind of several different types of operations: adding, subtracting, multiplying, dividing, all of those, just kind of an example of each one for you to use to help you work your assignment. Here's a little trickier division problem. I still have that I in the denominator. It's still a radical, but if you'll recall, anytime we were adding or subtracting radicals in the denominator, we'd multiply by the conjugate to get rid of it. Same deal here. I'm going to multiply by the conjugate. Remember, the conjugate is the same thing but with a different sign, so this will be a 2 minus I. 2 minus I. All right, so when I multiply, remember that it's in parentheses, so I'm going to have to distribute on the top and do FOIL on the bottom. So on the top, I'll have an 18 minus 9i. And on the bottom, when I do FOIL, I'll have first gets me a 4. Outer is a negative 2i. Inner is a positive 2i. And last is going to be a negative I squared. So remember, the reason we do the conjugate is because the outer and inner always drop out, and so the I is going to go away. And this is really a minus negative 1, so that's going to become a positive 1. So I end up with an 18 minus 9i over 5. But one of the things we're kind of particular about when we're writing complex numbers is we kind of like that format, that a plus bi, which makes the a part, the real part, separate from the imaginary part. So I wouldn't actually leave this complex number as a big fraction. I'd go ahead and separate it out, and I'd write it as 18/5 minus 9/5, and then I tack that I on the back side. So you kind of see the a and the b, what those values are. And then that would be my final answer. All right, let's try one more of these, a little bit trickier because the numerator is a binomial. So on the bottom, we got to multiply by the conjugate, 3 plus 5i. Same thing on the top. Now I'm going to have to FOIL on the top on this one, so I'll have a 6. Outer is a 10i. Inner is a 3i. Last is a 5i squared. On the bottom, when I FOIL, I'm going to have a 9 plus 15i. Inner is a minus 15i. Last is a negative 25i squared. All right, then we have lots of simplifying. So on the top, I have a 5i squared, which is really a negative 5, with the 6, so that's a 1. and then combine the I terms, the imaginary parts, gets me a 13i. On the bottom, remember the goal was to get rid of the I, so there it is, those i's drop off. This minus 25i squared is really going to turn into a plus 25 because the I squared is a negative 1. 9 and 25 is 34. So then our last step is to kind of rewrite it and separate out the real part from the imaginary part. Sometimes you'll be able to reduce there. I can't on this one. That's a 34, sorry. I can't do any reducing on this, but look for that and reduce if you can. All right, one more of these. I kind of like these quantity squareds. On this one, last time I did FOIL on it, but I'd like to refresh your memory on doing that shortcut because it really does save us some time to be able to square a binomial without having to do FOIL on it. And you don't just distribute the squared. That doesn't happen. You have to have that middle term. So to square this binomial, remember you square the first term. You multiply the 2 and double it, so that would be a negative, it's a 20i, so it's going to be a negative 40i. And then the last is squaring the last number again, so it's going to be a positive 25i squared. Now, if you are stuck on doing FOIL, that's fine. Go do your FOIL. You should end up with the same thing once you simplify it. All right, and then on the top, I still have 3i. I haven't really done anything other than get rid of those parentheses. On the bottom, this 25i squared is really a negative 25. So I have a 16 minus the 25 would get me a negative 9 minus 40i, and on top I have a 3i. And so all of that was just pre-work. Now what we have to do is go multiply by the conjugate to get rid of the I in the denominator. So I have my negative 9 minus 40i, so I'm going to multiply by the conjugate, negative 9 plus 40i. Distribute on the top, so negative 27i plus 120i squared. On the bottom, I'm going to do FOIL of 81. Outer and inner are going to drop. I'm not even going to write them this time. And the last is going to get me a negative 1600 I squared. All right, let's simplify that mess up. Okay, so on the top, I'm going to write the real part first. So this 120i squared is really a negative 120 minus 27i. And on the bottom, I have an 81, which is really going to turn into a plus 1600 because of the I squared. So it's going to be 1681. And then let's just separate it out. So it's going to be a negative 120 over 1681 minus 27 over 1681 I. I don't know. I don't have my calculator with me right now. I'm going to assume that does not reduce. Maybe it does. I don't know. I'm going to go with it. So perhaps you've been wondering, you should have been wondering, like, why are we doing this? This seems kind of out of the blue compared to what we've been working on. We've been doing zeros and that kind of thing, and why all of a sudden are we doing complex number stuff? Well, here's the deal. What we've been doing is a lot of factoring to find zeros, but our reality is not everything is going to factor beautifully for us, and so sometimes if it doesn't factor, we'll go use the quadratic formula. Okay, so remember your quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac. Are you singing it? You should probably, I can't hardly say it without singing it. All over 2a. All right, so That's the quadratic formula, and that's what we'll use if we can't factor something. So this example right here, let's say, I'm not even going to try to factor it, we're just going to use the quadratic formula on it. Quadratic formula works even if it does factor, but I'm going to practice my quadratic formula, so it's going to be an x equals the opposite of b, so that'd be a positive 2. Remember that this is your a, this is your b, this is your c. And so a is equal to 3, b is a negative 2, and c is 5. All right, so back to quadratic formula. X equals the opposite of b plus or minus the square root of b squared, so negative 2 squared is a 4, minus 4 times 3 times 5, all over 2a. All right, now let's clean up the radical part. We have a 4 times a 3 times a 5. So we have 2 plus or minus. So that's 60. So 4 minus 60 is actually a negative 56. That's going to be a problem because we have a negative underneath the radical. All right. Oh, well, we know how to deal with that. That's a negative. It's an imaginary. So let's go ahead and let's reduce our negative 56 and pull out the negative 1. And 4 will go in there 14 times. And that's all over 2. Oops, sorry, I missed my negative on my 1 there. All right, so then what I end up with, coming up here now, x equals 2 plus or minus the negative root I is, or the root negative 1 is going to be an I, and then I have a 2 root 14. So I'm going to write the 2 root 14, and then I'll put the I on the end, all over 2. And then remember that you can reduce like this, but this 2 has to be able to reduce into both of these, not into the radical part, but in the number in front of it. And if it will, and this one reduces beautifully, then go ahead and reduce. So that's just going to be a 1 plus or minus. I could write the 1, but we usually don't. So I'll just write 1 plus or minus root 14 I. And so that's my 0. So like I said, we've been working with finding zeros. And so what's going to start happening more to us, they've been nice and everything has factored nicely. Now we're going to start getting some that won't factor. So we have to do this quadratic formula. And sometimes when you do the quadratic formula, you get imaginary answers. Now, just as a refresher, remember what that means in our graph. I'm just making this up. It isn't for this one. But remember when we had imaginary roots, when we did our bounce cut packet, it would come up here and it wouldn't create a 0. It would just create this extra little dip in the graph kind of thing. So that's what we're going to have going on when we start having these imaginary roots. We'll have extra little dips in our graphs. Okay, but that's all we're doing. Most of it's just working with those complex numbers today. We won't be doing any graphing or finding the zeros, just practicing our skills with our complex numbers today. Good luck.